Hello students, today we are going to talk about the topic calorimeter and principle of calorimetry. Now before starting with the topic, if you want to improve or excel in maths and science, then do check out the micro courses offered by InfinityLearn and don't forget to use the coupon code HQ10 for additional 10% discount. Now coming back to the topic, what is a calorimeter? So calorimeter is nothing but a cylindrical vessel which is used to measure the amount of heat gained or lost by a body when it is mixed with another body or substances. So basically the intention is that we will be putting two different substances in this particular vessel and both will be at different temperatures. Let us say first one is at a higher temperature T1 and the other one is at a lower temperature T2. Then this body which is at a higher temperature is going to lose heat and the other one which is the colder body is going to gain heat. Now in the calorimeter, we ensure that the heat is not lost to the environment and therefore the entire vessel is kept in a casing of wood which is a very bad conductor of heat, and the spacing between this wood and this particular vessel is filled by wool which is again a bad conductor. So by this what happens is there is no conduction of heat from the vessel to the outside. Also, to ensure that heat is not lost by means of radiation, the vessel that is used is made up of copper and the inner and outer surface of this copper is polished. And by polishing, it is ensured that the amount of radiation or the heat loss due to radiation is minimized. And finally, the top of the vessel is also covered by wooden lid to ensure that the heat does not pass on to the environment by means of convection. So as we know, heat can travel by means of conduction, by means of convection, and by means of radiation. So the effort is taken to minimize heat loss by all three methods over here to the environment. Now additionally, there are two more things which are used in this setup. One is a thermometer which gives us the reading of the temperature of the mixture, and we also have a stirrer over here which is used to mix the mixture properly so that heat is uniformly distributed. Now one very important question that arises is ki the heat lost by the hotter body will also be absorbed by this copper vessel and the stirrer that we are going to use over here, and for the same reason this copper these vessels which are made up of copper are very thin. Due to copper, the specific heat capacity of this vessel is very low. When I say specific heat capacity is very low, it means that it gets heated up equal to the mixture very easily with very less amount of heat. So the amount of heat consumed or used or absorbed by this vessel is relatively very less and can be neglected for calculation purpose. So I hope calorimeter setup is clear to everyone. Now let us quickly understand the principle of method of mixtures. Principle of method of mixture says if in this calorimeter we add two substances, one with a higher temperature and one with a lower temperature, the heat energy lost by the hot body will be equal to heat gained by the cold body. And this is only possible if the entire setup is isolated from the external environment. And as we saw in the last slide, we have made arrangement so that heat is not lost to the environment. Let us say the hot body is having mass m1 and the hot body ka specific heat capacity is given by C1 and the initial temperature of the hot body is T1. Secondly, the cold body, let us say its mass is m2, its specific heat capacity is C2 and initial temperature before mixing is T2. Now after mixing, what happens is the temperature of the first body drops and the temperature of the second body rises and they arrive to a common temperature T. So for the first case, the change in temperature for the hot body the change in temperature will be how much? So it will be T1 minus T. And for the second body, the cold body, the change in temperature will be how much? It will be T minus T2. Next thing is specific heat capacity का formula क्या है? It is the amount of heat absorbed या lost divided by mass into change in temperature. So from here what we have is Q is equal to M into C into delta T. So by using these three values, let us understand the heat lost will be how much. So the heat lost by the hot body will be M1 C1 into delta T, which is given by T1 minus T, and the heat gained by the cold body will be how much? It will be M2 C2 T minus T2. And as we said by the principle of method of mixture, heat loss will be equal to heat gained. Heat lost by the hot body will be equal to heat gained by the cold body. So in this equation, if we know the masses of both the bodies and we have already recorded the temperature by means of thermometer, then if I know the specific heat capacity of one body, what I can do is I can calculate the specific heat capacity of another body. And that is how this formula is useful. I hope this part is clear to everyone. Next, let us talk about natural phenomena and consequences of high specific heat capacity of water. Now, specific heat capacity of water is 4200 joules per kg per Kelvin, which means if water ka 1 kg of water has to be heated by 1 Kelvin or 1 degree Celsius, the amount of heat required is 4200 joules, or you can also write it in terms of calories. Equivalently, if the water is cooled by 1 Kelvin, 1 kg water is cooled by 1 Kelvin, amount of heat given out will be 4200 joules or 1000 calories. Now because of this, the very first phenomena that we see is the climate near the seashore is very moderate. And what do we mean by this is we have land near this seashore. Now during daytime, land gets heated very quickly and the air above the land becomes hot, but the air above the sea still remains cold because water takes time to heat up. Now because of this, cold air from sea flows towards land and this is called as sea breeze. Similarly, in the evening time, after the sunset, now the water in the sea is very hot compared to land and land quickly cools down. Now because of this, there is this breeze that flows from land towards the sea, which makes the environment moderate. Now the next uses or next phenomena that we observe is that many people use hot water bottle for fermentation. We see many people who have pains, back pains or joint pains, they use this hot water bottle for getting relieved from the pain. Reason being, the water does not lose heat very quickly, and as it cools down, it gives out large amount of heat which is available for a longer time, and therefore hot water bottles are used for fermentation. Next, we also have water as an effective coolant, and that is why we find that automobile radiators, they use water for cooling, generators use water for cooling, and the water can be made to flow through the machines which are hot enough, and while flowing the waters, they take out the heat effectively from the machines without much rise in its temperature. Next is, in cold countries, water is used as a reservoir for wine and juice bottles to avoid their freezing. The reason is that water has once again very high specific heat capacity and it can give out a large amount of heat even when the temperature outside is very low, and therefore bottle they remains warm when kept in water and they do not freeze. Next is, farmers they fill their fields with water to protect the crops from frost. Now we know that crops they take water from the ground via the capillaries, and if the temperature falls to 0 degrees Celsius, then in that case the capillaries might burst due to expansion of water during freezing. This comes due to anomalous behavior of water, and to avoid this the farmers they flood their fields with water, and as the water has high specific heat capacity, it does not allow the temperature to fall to 0 degrees Celsius, even if the surrounding temperature falls up to 0 degree Celsius. And lastly, all plants and animals have high content of water in their bodies, around 80%, and this helps to maintain the same temperature of the body in all the seasons. So I hope we are clear with what is calorimeter and the principle of calorimetry. Let us quickly check the examples of high and low specific heat capacity substances. The first example is the base of a cooking pan, which is made thick. By making it thick, the heat capacity of the pan goes up, as heat capacity is directly proportional to mass of the substance, due to which the base of the cooking pan heats slowly, and it provides enough amount of heat for the food to cook, and even after cooking it gives out heat slowly and keeps the food warm for a longer time. The second example is base of an electric press. Again, it is made thick and heavy, by which the heat capacity increases and it remains hot for a longer duration even after the current is switched off. And finally, we have an example of vessel that is used for measurement of heat in calorimeter, as already discussed earlier. We know that the vessel is made up of copper because it has a very low specific heat capacity, and the vessel is made very thin so that the heat capacity decreases with less mass. Now, because of this, what happens is the vessel can easily attain the temperature of the substances present inside it without absorbing too much heat, as low specific heat capacity material requires very low heat to attain a particular temperature. So these are the examples that we have. Thank you very much.